So this is going to be an amazing video in which we're going to make sense of the famous crossover rate and the incremental cash flow method, something that students always find a way to kind of like not really, love it. And hopefully in this video, you're going to be empowered to understand every single step related to this question. And not only that, know how to solve related questions effectively and easily. In this video, you're going to understand a few topics. You're going to understand how to find a crossover rate. You're going to understand everything you need to know about the incremental cash flow method, and you're going to understand how to draw essentially a graph displaying the relationship between the NPV and the IRR in order to figure out, well, when does one project yield a higher NPV than another one? So these are a bunch of different concepts that you'll be able to master in this video. The reason why you'll be able to master these concepts, it's because we're going to be looking at two distinct questions related to the crossover rate that you may see on a final exam question. These are from past exams in which I, added my own juice, my own sauce to it, and you're going to be able to really get a sense of what's up. Now, this is extremely important for people who are studying in their undergrad in a commerce program, such as at Demystifying for Comp 308, and even at McGill, UPenn, or anything of the sort. Even people taking their MBA, first time getting exposure to finance problems, this will help you out. And perhaps even people doing their level 1 CFA, understanding the relationship between the IRR and the NPV is something crucial for anybody within the realm of finance. So let's jump into it. This will be maybe a long one, but it's going to be a fun one. And if I talk too much, don't hesitate to skip through the video. I just want to give you exposure and empower you and kind of like help you with the little gaps that are here and there. Okay, so you work as an associate at KKR's New York office. I mean, listen, private equity must be paradise. And your VP, well, she or he asks you to evaluate the following two projects. You're going to have Project X, right, and Project Y. Project X, okay, will cost the firm, okay, $25,000. However, it'll generate annual cash flows of $3,750 in perpetuity. So every single year, forever, it'll generate this amount. That's pretty awesome news. On the other hand, Project Y will cost $17,500 at onset, and it'll generate annual cash flows, okay, of $2,800 in perpetuity. Now, given the above information, you have requirement 1 and requirement 2. Requirement 1, it requires you, and we'll highlight it in red, it requires you to find the crossover rate between these two projects, okay? Now, for some reason, they were written poorly. This should be Project X, okay? So this is between Project X and Project Y, but for some reason, there's a little typo. And then we want to look at the relationship of these two projects on a graph that displays a relationship between the NPV and IRR. So that's what we're going to do here. Okay. So we're going to draw a graph displaying the relationship between the NPV and IRR. With number 1, the first step, right, is to find the crossover rate. Now, how do you find a crossover rate, right? What is that all about? How do we use the incremental cash flow method to our advantage? Well, we need to take a step back. Okay. First and foremost, we have two projects. Okay. And these two projects, right, they may have a point at which their NPV are going to be equal to each other, right? In which essentially the present value adjusted for the initial investment of Project X and the present value adjusted for the initial investment of Project Y will be equal to each other. What's really awesome is that the point at which they're going to be equal to each other was going to be a specific point. It's going to be a specific discount rate. At that discount rate, the two projects will have a similar, or not even a similar, they'll have the same NPV. And we're going to try to solve for that right now. Okay, so the incremental cash flow method. So I'm going to zoom in a little bit. Sorry about that. And we're really going to have like a little section of our page that kind of discusses what the incremental cash flow method is all about. So not even step 1, we're just going to highlight this as being the incremental cash flow method. Okay, the incremental CF method. Okay, and the incremental cash flow method is really straightforward. We want to find the point at which the NPV, okay, of Project A is equal to the NPV of Project B. Okay, that's what this tries to do. It's really as easy as that. That's our objective, that's our goal. But just looking at this like that, it may seem like a difficult task. Like, how the heck am I supposed to go about this? How am I supposed to solve for this given point at which the NPV of A will be equal to the NPV of project B? And I'm going to add another little like note here. This is, okay, this is, I guess, when the K, this will be at a specific K, okay? The NPV of A will be equal to the NPV of project B at a specific K, all right? So that's just another thing to remember. And I'll erase it for now, but I want you to understand that this will happen at a specific K, and I already addressed that. So what we can do is we could kind of use the information, use the tools that we have at our disposal with this notion of NPV to try to actually find the point at which these two projects will be equal to each other. Once again, to find the discount rate, to find the K at which these two projects are equal to each other. So if NPV A is equal to NPV B, I'm going to kind of work with you. We're going to do something fun. If NPV A is equal to NPV B, technically, we could say that NPV B less NPV A should be equal to 0. Does that make sense to you? Let me give you an example. Let's say that NPV B was 15, and NPV A, because they're equal to each other, is 15. Well, 15 minus 15 gives you 0. I feel like that's a topic that we could all understand. If these two NPVs are the same, well, if you do 15 minus 15, you're going to get 0. All right. But what's really interesting here is that we actually know something about NPVs, right? And I hope this like kind of rings a bell to you, and we'll highlight it once again in yellow. The point at which an NPV is equal to 0 is a very interesting point. It's the point at which, right? The point at which your NPV is equal to 0, well, that's the K that is equal to the IRR, right? The IRR is a very cool point because it's an objective point at which your NPV is equal to 0. But now we're telling you, hey, the NPV B minus NPV A is equal to 0. Well, I mean, maybe that discount rate that we're looking for is the IRR of the difference between these two projects. Okay, let me take a deeper step in. All right, let's assume that the initial investment of these projects is equal to 0. Technically, what you're going to do is simply the present value of B minus the present value of A, and that's going to give you 0, assuming they have no initial investment. I'm kind of just running with it. Don't you worry. I'm going to do the question with you. I just want to give you some context, and you could skip this if this doesn't help. So in other words, we could say, for example, assuming that they're perpetuities, we would say that payment B over K minus payment A over K. Of course, they would have different initial investments. That's how they would be equal to each other. Don't you worry, I understand. Is equal to 0. And what's awesome here is that we know that the point that will allow this to happen is a specific point. It's a specific K. And what's awesome is that we know that a point, right, that gives you a difference of 0, right? A point that yields 0, that specific K that yields 0, right, on the other side, as you can notice, well, that's the IRR, okay? We understand that. So what I'm trying to get to here, okay? What I'm trying to get to is that the incremental cash flow method, why it's so interesting, it's because it allows us, so I'm going to try to maybe draw like a little arrow if it allows me to. It doesn't allow me to. If you look at all my videos, you always see me like struggling to find a way to draw a nice arrow. But anyways, what's awesome here is that the IRR of the incremental cash flows method is the crossover rate. The crossover rate, the crossover point, however you want to call it. So that's what this proof really tries to do for you. It tries to let you know that essentially we're simply going to find the IRR of the difference of these two cash flows. And that's going to give us a crossover point because of this simple proof. And I hope this kind of helped you, give you some context. Another way to really look at it is that we could say that we could treat the difference between two cash flows two sets of cash flows as being an individual cash flow in itself. And we're just going to solve for the IRR of that individual cash flow. So in other words, the point at which the NPV is 0 for that individual cash flow. So there's a bunch of different ways to look at it. And I have a bunch of different videos that actually tackles this. But hopefully this gave you like an introduction to what the incremental cash flow method is all about. So knowing that, we could actually hop into the question and solve for the crossover point. Okay, it's super easy for this question, so it's going to be awesome. All right, so let's go ahead and I'm going to zoom in once again. I'm sorry, I just want it to be as comprehensive as possible and like well written. So when you look at this afterwards, it's easy. So let's go and solve for the crossover point or the crossover rate. This really is, it's the same thing. All right, so we're going to solve for the crossover rate. Now, sorry, there's noise outside. I totally apologize, but it's summer. I got to leave the windows open or else I'll burn alive. So in this case, once again, we know that we could find the crossover rate of two projects by simply doing project B minus project A or the other way around. And solving for that K that allows that to be equal to 0 will be your crossover point. So in this case, what we do technically is we do this. Okay, so we could use a table that looks like this, in which you have a given year, then you have a given cash flow. So you can use a little table like that. It's a really cool way to visualize what the heck is going on. Okay, so you would have year 0, you would have year 1. Year 0 obviously is your initial investment, and year 1 will be, of course, essentially your cash flow for year 1. But in this case, we're looking at something very specific because we're looking at perpetuities. So perpetuities. So we're going to have to kind of use some magic tricks to help us out. And yeah, we should get that. So I'm just drawing out the table for you. Trust me, this will be helpful. Okay, so in this case, we're using a little table that's going to make this easier for us. Some exam questions will give you the table from the very beginning, but in this case, we don't have it. So I'm just going to make it a little bit easier for us. So we know that project, I'll just zoom out a little bit so we can highlight our information again. But we know that we have project X and project Y. In this case, just to make it easier for us, we're going to call project X project A and project Y project B, just so it's simple for you to remember the things. So we know that project A, its initial investment, so the cash flow at year 0, sorry, will be equal to $25,000. So 25K, right? And we know for project B, it's equal to, and I guess I'll put different colors such that it's like kind of, easier to read. We're gonna have minus 25K here, and we're gonna have minus 17.5K here. And then for year 1 onwards, in this case, because it's a perpetuity, we're gonna put like infinity. But for project A, we have cash flows of 3.75K forever. And for project B, we have cash flows of 2.8K forever. Okay, and we know that under the incremental cash flow method, what you're going to do is you're going to find a difference between these two projects. So what we can do here is minus 17.5 minus 25 is going to give you 7.5K. So we know here that we're going to have 7.5K as our initial investment difference. And here we're going to have essentially 2.8 minus 3.75. I'm not going to try to do the mental math. I'm too lazy for that. Minus 0.75. We're going to have minus 0.95. All right. So far, so good. We have the difference in the cash flows, right, for year 0, and then the difference in the perpetual cash flows for project B and project A. Once again, if that's not too clear, remember that in the question, they told you that these cash flows will be generated in perpetuity, so forever. So we just need to find a difference for 1 year, and you'll see how easy it is afterwards. So now that we have this information, the reason why this information is so damn important. Okay, so I'm going to go ahead and highlight it for you. Why this information is so damn important? Well, you'll see why in just a second. So we can go ahead and highlight this, and I'm gonna try to be cute real quick. I'm trying to make this like nice. Yeah. No, we don't need to do all that. Anyways, you're seeing me, my natural element, trying to make my notes look cute. But what we know here, once again, is that the difference between these two projects, right? Well, when it's equal to 0, it will yield the crossover point. And we know that the crossover point is the IRR of the difference between two projects. So in this case, we could say that 0 is equal to 7.5K, right? I guess we could start with the cash flows. We'll do this instead. We'll do minus 0.95K over K plus, minus, sorry, 7.5K. In other words, if this isn't too clear for you, I'll highlight this in yellow. I'll highlight this in yellow and just really make it super clear to you. So when you review these notes, this is the present value of CFs. And this is the initial investment. So just such that, you understand that this is the NPV formula. And in this case, we're solving for K, which is our going to be our IRR. In other words, i.e. your crossover rate. Okay, so I really want you to be able to review these notes and feel comfortable, like you have all the information out there. So that's why I'm kind of going slowly. So once again, don't hesitate to skip through the video. I get it, sometimes I talk too much. So in this case, we're going to solve for K. We're going to solve for K. And I'm going to be a lazy person, and I'm just going to plug it into my symbol lab, but it's pretty straightforward math. So also, by the way, if you saw my previous IRR videos, you could actually just plug this in within your calculator and it'll give you the answer. But I like to use math to my advantage here, symbol lab to my advantage. So we're going to have 0.95 over x minus 7.5. And that should give us an interesting point. And it's going to give us a negative value here, and that's okay. I didn't plan this ahead of time. So your K is going to be 0.12666 periodic. So in other words, your K will be equal to minus 12.67%. Now, on an exam, I feel like teachers will be nicer to you. They won't give you a value that's actually negative. But in this case, it's simply telling you that the crossover rate, the point at which these projects will yield the same IRR, will be a negative IRR, okay? It happens to the best of us, but you can still run a proof just to be sure that this is correct. Over minus 0.1267, and you're gonna get 7.5K, all right? So in this case, your IRR for this project is equal to minus 12.67%. So in other words, the intersection of these two projects will occur at minus 12.67%. Such that for this question, I'm not going to go ahead and draw a graph to display when a project is better than the other one, because it won't yield to a conclusive, exam-like solution. But what I do want you to understand is that that's how we use the incremental cash flow method. Okay, notice how we just had to find the difference between project B and project A, and then we solve for the K because we know that that IRR will be your crossover point between these two projects.